So perpendicular lines, slopes are negative reciprocals, or the product equals -1. So the slope of the line perpendicular is going to be -1/2, so that the product of 2 and -1/2 is -1, or take the negative reciprocal of 2. Now I have y minus y1 equals the slope times x minus x1. This is also a part 1 question, by the way, worth 1 point. So I have y minus 6 equals -1/2 x plus 1. Add 6, y equals -1/2 x plus 7. Okay. So what are you looking for in a domain problem? 1, you're looking so that the denominator is not equal to 0. That's one thing you're looking for. And then you're looking for the number underneath the radical has to be greater than or equal to 0. So those are the two things you're looking for. So what you have in this problem is a radical, and you have it in the denominator. So what's underneath that radical has to stay greater than or equal to 0. Now here the radical only needs to stay, I don't want to do that. The radical only needs to stay greater than 0, but if it's in the denominator, it has to be greater than or equal to 0. So I just need to solve this. Negative x is greater than or equal to -4, or x is less than or equal to 4. As long as I put in a number less than, not less than or equal to, okay, I have to stay greater than or equal to 0, but in this case, it can't even equal 0. I simply want it greater than 0 here because it's in the denominator. If that radical was in the numerator, it would be greater than or equal to 4. It's in the denominator, so it cannot equal 4 because you'd have 4 minus 4, the square root of 0 is 0, undefined. Let's take a second problem on this.
So then would you write the domain and implementation like that?
So we solve each of these two for greater than or equal to 0. Take a look at the graph. Where do they intersect, overlap? Greater than or equal to 7/4 is from -7/4 to the right. Less than or equal to 4/3 is from 4/3 to the left. What they have in common is between a -7/4 and 4/3, inclusive of both endpoints.